Yeah, welcome on to my talk. Today I wanted to talk about Glider, like what is Glider and how I've been able to use that to find vulnerabilities. And we can use Glider to query smart contracts for any kind of bug patterns and use this to find, for example, like vulnerabilities. So before we dive into that, a little bit about me. My name is Kasper. I'm the head of audits at Hexens. Hexens is a cybersecurity firm. We do Web3 audits, so smart contracts. We do ZK, cryptography. We do Web2 pen tests. And during my time at Hexens, I've been able to do some very cool audits for like 1-inch, Lido, Polygon, Eigenlayer. And well, before Hexens and in my free time, I also do bug bounty. So I really love doing bug bounty. It has basically what's gotten me my like hard technical skills. So like a couple of years ago, I started doing CTFs and Web2 bug bounty at HackerOne, Integrity. And then I think like 2.5 years ago, I started doing bug bounty at Immunify. I'm currently like rank 34 on the leaderboard. Yeah, so yeah, let's talk about Glider. What is Glider? And so Glider is a query framework that has been developed by Hexens. It's static analysis, and we can query smart contracts for code patterns. So there's a query language, which is in Python, and it gives us like a query API. So there's a Glider API that we can use to create these queries and then look for patterns in all smart contracts across the entire blockchain. So it is currently connected to Ethereum mainnet, and we can write a query, run it against mainnet, and then basically give us any kind of results that we want. So as a security researcher, I'm standing here just to give you my experience of Glider as an independent researcher. But you can also use Glider to basically analyze smart contracts on your chain for data science or compliance purposes. Right, so let's take a look at what Glider actually looks like. So it's currently a web UI. So this is hosted on our bug bounty platform. I'll give you the link at the end. So this is what the UI currently looks like. At the left, you'll see your queries, and we have a nice VS Code-like view where we can write our Python query. So we will go over some queries in more depth, but this is just to give you kind of an overview of what it looks like. Yeah, so at the right, we can see like the results. In this case, I've returned like a list of functions, so you'll see a couple of different functions with our contract address and name. And then from there, we can do like manual review from like, is that maybe vulnerable? That's purely up to you. You can choose like what you want to return to the output. We'll get into that a bit more later. And at the bottom, we see like the results. So in this case, I wrote this query. It has been executed across entire mainnet, has given me 120 results, so that passed like my filter. And then, yeah, it took like 6 seconds. All right, so this is basically my first success story. You may have heard of SoftDAO. It's a pretty small organization, but they have a DAO, on-chain governance. And yeah, basically during my like bug bounty before Hexens, I very focused on like governance bugs. So I really liked breaking governance, on-chain governance. And this was a bug in the voting process, right? So I found this critical bug where you could have infinite voting power in their proposals. So this is actually like a bug that I found like 2 years ago in some other program on Immunify. And I was like, okay, I can take this bug pattern because it's very specific. I create a query and run it across all contracts on mainnet. And then it just rolled out a couple of instances where this was applicable. Of course, a couple of those are probably like that. So they're like transactions or contracts that didn't have transactions for like 2 years. Yeah, nothing to do than to disregard those. But there was like one live DAO that was still ongoing. That was SoftDAO. So yeah, we contacted them, had the whole disclosure, and yeah, in the end, a bug bounty was paid, and an article was published. So if you Google like remedy and SoftDAO, you'll probably find the article about the bug. Cool. So let's get a bit more technical. We can look at some code snippets that of bug patterns that I found in the past, and then look at like what a query might look like to find those. So if you're familiar with on-chain governance, like ERT 20 votes or Governor Alpha, those kind of contracts, then you might have seen this before. So this is basically like a function that returns the voting power of a user in the past. So it is normally called like get past votes. Sometimes it's called get prior votes. And in this case, you can see there's a require. And the mistake here is basically that there is a less than or equal to. So this basically means that if you give the current block number, it will still return your voting power. So it is also in the present. It's not just in the past. And yeah, this might lead to mistakes. So this by itself is not necessarily impactful, but if it's like combined with a proposal that starts immediately, you might be able to vote, move around some voting power, and then vote again from another account. That would give you infinite voting power. And this was also the case with SoftDAO. So yeah, this is basically what led to that bug disclosure. So it's very simple, and the query will be very simple as well. Like it's Python, and there's lots and lots of API from Glider. So there's many ways that you can actually write this query. In this case, I've chosen for a very simple way as the first query to just show you. So basically, in the first, it's basically two passes, right? So in the first one, I use like purely Glider API. So the first call is just functions, and what this does is it gives me like a list of all functions on Ethereum mainnet. And then I want to filter these down to just the functions with these specific names. So yeah, with the second function, with one of the names, it just filters it down to just those functions with those names, very specific. And then I execute it. So the 10,000 is just the limit to make it a bit faster. So it'll just find me like 10,000 occurrences. And then in the second pass, I use more like a real Python just to do a for loop across all of the results. And in this case, I do a very simple, a bit of a hacky way of looking if there's like basically the pattern that I'm looking for. I check the source code and just do like a string exists in there. But this is very fast, so I do like to use that sometimes. But yeah, Glider API gives us the ability to also just look into, so if you had functions, these would be function calls. You can look at the parameters, their types, basically their instructions, which function call those functions, or vice versa, like which function does this function call. Basically anything you can imagine can be done. So this is a second bug pattern. This is again with governance. Most of my bug patterns are with governance. So this is a delegation override. So if you're familiar with delegation, you can give voting power to someone else. And there's usually a function delegate to do this. And some protocols, they like to override the delegates function as well, which basically does that if you have never delegated to anyone, so your internal mapping is address 0, then it would return yourself, right? So you're always delegated to yourself. And that's perfectly fine if you like take something else into account as well. And that's basically that you shouldn't be able to delegate to address 0. If you are able to delegate to address 0, it basically messes up the accounting, right? So it would see yourself as the from address, you'd be delegating to address 0, and that basically means that your voting power would be burned. And then at the end, it would still think you're delegated to yourself, because address 0 is kind of a magic value, and your voting power would be gone. All right, so this is the query that I wrote in the beginning to find this. We'll just go over this quickly. Like in the beginning, again, I used the functions Glider API to get all the functions, and I filter this with signatures. So again, very specific. Just have a list of all of the interesting functions. And then I loop again through those functions, look for address 0 in there. So that's basically the address 0 check. So I just want to find that. And then I also want to know, like, does the delegate function not have like an address 0 check? So like I said, like this is only an impactful bug if you are actually able to delegate to address 0. So what I do, in the middle you see that I try to, does this work? Okay, well anyway, so in the middle you'll see that yeah, I have the functions, so I do another loop over basically the functions. I go to get contract, so I move up from this function to the contract that this function holds, and then I do the API call functions again. So I move down again, but now I have all of the functions in this contract. And then I filter again like for functions with calling names. So I get all of the functions that call the underscore delegate function. And that's the interesting one, because that's the one that changes the delegation. So I want to know, do those have address 0 checks? And that's what I do again, like with the source code string check. And in the end, I want to return the underscore delegate function. So I get it again. I just want to return that specific function, because that's one of the beautiful things with Collider, is that you can make the query any way you want. You can basically filter for anything else, but you can keep like data from previous filters as well. So because it's Python, you can just write whatever you want. You can have like a filter, use that data for your next filter, and then you can return something else that came from that data as well. So you can shape it basically any kind you want, any way you want. All right. Then the last bug pattern that I just want to look at quickly is this layer 0 reentrancy. You may have heard about it, like the layer 0 endpoints. They have the send function with a refund address. So that's the fourth parameter you'll see at the right. Usually this is set to message sender. So this is a vulnerability not in layer 0, but in protocols that's built on top of layer 0. So yeah, the refund address is basically the address that gets the native fee, so the native ETH that is sent to this endpoint back in case there was sent too much. That happens quite a lot. So yeah, that this ETH should be returned to basically the user, right? They are paying for sending some message across to an L2. So yeah, this is usually set to message sender, and that's perfectly fine. But this is done with a call. So the application that builds on top of it needs to take into account that there is potential for reentrancy. So I was basically looking for protocols that use this function. So again, in the beginning, you'll see instructions. This is similar to functions, but it gives me all instructions on mainnet. So an instruction is basically like a line of code that's ended with a semicolon. And so besides function and instructions, you also have contracts, you have variables, parameters, you have a bunch of things. And then in the instructions, I filter down to call instructions that call this specific signature. So this is the signature of the layer 0 endpoint. And then in there, I do, we'll go over this. So like, I just go over all of the instructions. I look for storage rights, basically, because as is the case with all reentrancy, right? It's only vulnerable if there's a storage right or external call afterwards. There's no point in, it's not impactful if you, okay. Yeah, good. All right, so basically, yeah, here. So I want to know, like, is there any storage right after this call instruction to the layer 0 endpoints? Because this endpoint would give me execution as attacker. So I want to know if there's like any potential there. So this is the Glider API. I can, on this instruction, I can just do next instructions, which would give me all instructions after this call inside of the function. So I simply check if they're storage right or external call. And then you still need to check like the function that would call this internal function, right? So so this function that does this layer 0 send, it might have been called by another function inside of the contract. So we also need to like bubble up and then check if there's a storage right after that as well. So that's what's done in after this. So I just basically, yeah, bubble up like any caller functions. I would add them again. So I go up and up again until the external function and see if there's like any storage rights, because that would make it vulnerable. And this is exactly what happened. So I did find like a protocol that was vulnerable to this. This was called layer 0 domains. It was not affiliated with layer 0 at all. It was like a name service on layer 0. And yeah, this was vulnerable. Right, so that's basically it. Those 3 bug patterns I wanted to discuss and show you like the queries that you can make. Yeah, and you can try it out yourself as well. It's on collide.r.xyz. you'll be able to sign up. So r.xyz is our bug bounty platform. It's called Remedy. And on there, we have this tool, Glider, that you're able to use immediately when you create an account. You'll have access to testnet. And we also have Google's forum right now to basically request access to mainnet as well. Basically, the QR is a link to our community. So this was a nice slide with our community. But basically, we have a Discord where I'm in there, all our employees are in there. Our CTO, who is the head of Glider, he's in there as well. And you'll be able to like ask questions in there. So yeah, this QR should lead you to this Discord. And then in there you can ask any questions, like if you're trying Glider or you have like a very cool idea and you want to get mainnet access, let us know. No problem. Yeah, this is our bug bounty platform as well. It's also interesting for projects if you want to be listed. We have 0 fees during our beta phase, which is at least this whole year. We do charging ourselves, so no invalid reports for you to look at. And yeah, we already have some cool big bounties listed as well.